Okay, so we're back at it, and we're talking about Newman projections and all the horror stories that come along with these things. And here's another example problem, and this is the only thing we're going to be doing in this video. So problem 42 says using the Newman projections, draw the most stable conformer. Well, thank goodness, right? They didn't tell me draw all of them. I mean, I don't want to be drawing all of them. Good. Most stable. That's all that they want. Okay, so the most stable conformer for each of the following. And it says for part A, 3-methylpentane viewed along the C2-C3 bond. Okay, that's not going to be hard. We can do this. So pentane is 5. 1, 2, 3, 4, 5. And 3, on carbon 3, I have a methyl group. So there we go. So I need to draw this as a Newman projection around C2C3. All right, so here's carbon 2 and there's carbon 3. So right here is where I need to focus on, right there. So that's going to be a circle with a dot. And of course, I have 3 bonds. It tells me the most stable. So I know that we're going to have a staggered conformer in order to do this. And I have to keep in mind the 2 bulkiest groups directly across from each other if we can do it. All right, so on carbon 2, which is this dot, that's the first one that's pointed toward me, what do I have? Well, I didn't draw everything here. I could have, but I didn't. I think we're getting past that point at this point. That carbon has 2 hydrogens, and it has this methyl group that's a CH3 group. All right, so CH3 and then a hydrogen and a hydrogen. So there we go. There's the 3 on the first one. On carbon 3, the circle toward the back, what 3 groups do I need to put on here? Well, it looks like I need to put on a methyl group. It also looks like I need to add on an ethyl group. And of course, I need to add on a hydrogen for the third one. Now, the question says the most stable. So the bigger houses, the further apart they want to be. What does that mean? Well, this is an ethyl group. This is a big O mansion. And that ethyl group better be far away from that methyl that's on my first carbon. So because of that, CH2, CH3 should be in this location, anti. This is the staggered conformer that it prefers to be in. So there's one of the groups, and that biggest group is furthest away from the group on the front side. So that sets the template up. Now I've got to go in and do my methyl group and my hydrogen. So there we go. I know that these 2 methyl groups are near each other, but folks, there's no way around it. I mean, this is just the way the molecule is going to have to deal with it. So that has a methyl group on the back side. You can't just delete that group. There's nowhere else for it to go. You're already, by defaulting, getting this biggest house over on this side, directly opposite of that one. And whatever comes on the block, that's just what comes to the block. And this CH3 group has to be there. I know it's right beside of that CH3 group, but there's nothing else that you can do about it. So this is the most stable conformer around the C2-C3 bond of that particular molecule. All right? Okay, B. B says 3-methyl hexane. Okay, so 1, 2, 3, 4, 5, 6. On carbon number 3, I have a methyl group. And they want me to focus on the 3rd and 4th carbon here. All right, so carbon 1, carbon 2, carbon 3, and carbon 4. This is where they want me to go. So I've got to draw this thing in the most stable conformer out of all the choices that are out there. All right, so once again, I start off with that template. There's my 2 carbons that I want to focus on. So 3 bonds on the front, 3 bonds to the back. There we go. All right, so on this first carbon, this front one, I said first, but the front one, what do I have on it? Well, I've got an ethyl, I have a methyl, and I have a hydrogen that's not drawn. That's my third one. My fourth bond goes to that carbon. So I have a hydrogen, a methyl group, and an ethyl group. Well, the way that I work, the way that I think, ethyl group is bigger. So I have that pointed straight up. So CH2, CH3, and then I have a methyl group, CH3, and then a hydrogen. So those are the three that are attached to that front end carbon. The fourth bond goes to the back end carbon. Now, what does that one have on it? That one has ethyl, and what's not drawn are two hydrogens. So I have a ethyl group and two hydrogens that I need to assign to the back end carbon. Well, the most stable conformer is going to take the ethyl group, which is a big old mansion, and it's going to point it away from that big old mansion right there. They need to be anti of each other. All right, well, if they're anti of each other, then that means it's going to force it here, CH2, CH3. And you might be like, well, wait a minute. Now these two things are close together. They are, but folks, there's no other choice. Your other choice would have been to put the ethyl group here, and they would be side by side. Or to put the ethyl group here, and that would be side by side. And this is going to be better for it. I know that it has a neighbor, but that house is not as big. So there's a little bit more room between them, and it lowers the torsional strain that we will see on the molecule because of that. So CH2, and then the other two things are going to be hydrogens. So there you go. There's the most stable conformer for that particular molecule around C3, C4. All right, so finally for C, I have 3,3-dimethyl hexane. So, oh gosh, there's even more. All right, so 1, 2, 3, 4, 5, and 6. So there's hexane. On carbon number 3, I have a methyl group, and on carbon number 3, I have a methyl group. So there's two of them here. And it says view it along the C3-C4 bond. Okay, so there's my third carbon, and there's my fourth carbon. So this is what I need to focus on right there. So over here, I'll draw the Newman projection, and I'll draw the three bonds from it because I know they want the most stable. So it's going to have to be staggered. On the front side carbon, what do I have attached? I have a ethyl, a methyl, and a methyl. All three of those need to go into the same carbon. This is crowded, but that's the way it's going to be. All right, so the ethyl group is the biggest. I normally point it straight up. No rhyme or reason. That's just what I do. And then here is a methyl group, and there is a methyl group. So there we go. There's the three on the front side. On the back side carbon, what do we have attached to it? I have an ethyl group as well as two hydrogens. All right, so what do we do here? Well, I need it anti of each other. So I'm kind of caught in between two evils here. By default, it's going to go here like we've done in the other ones. My ethyl group goes directly across the biggest one from here. But in doing so, look, it's going to sandwich it in between two methyl groups. Folks, there's nothing I can do about it, though. That's just the way it's going to be. Because if I drew the methyl here, or the ethyl here, that would be in between a big O mansion and a big house, right? If I drew the ethyl group here at this position, that would still be between a big O mansion and a big house. By drawing it anti, well, it's between two houses that are pretty big, but nothing like a mansion would be. So this is going to give it the best room possible. I know it doesn't look like it on a sheet of paper, but that is going to be the most stable conformer because this largest group on the front end carbon is directly across in the anti-position of the largest group of the back end carbon, and that's what this is all about. So the other two will get hydrogens. So don't let it throw you for a trick. Don't let it throw you for a loop. That's just the way that it is. So you have to regard and compare the largest groups on the front carbon and on the back carbon. That is how you're going to get the most stable conformer out of the bunch. All right, so there's three more examples of Newman projections. And again, I hope that you feel a little bit more comfortable with them now that we've worked with them a little bit more and more over time and done some more examples with them. But we're not yet finished with conformers. All right. So this is conformers of a sigma bond, a single bond, because they constantly rotate. And in the next video, we're going to focus on conformers of cyclohexane, a ring structure. So there's a reason that we focus on cyclohexane, and there is a reason that we talk about conformers of that group, and you'll be able to see that in the upcoming videos. So that's where I'm going to stop here. No more Newman projections, no more single bonds, no more straight chains. And now we're going to turn our focus to ring structures instead, and in specifically towards cyclohexane.